Okay, this question is a combination of mensuration, and the shape that we're talking about is a prism. And it also has some trigo, which is on the last part, the angle of elevation. So I'm going to run through every part. Most people get stuck in the elevation, the last part, the angle of elevation. Okay, so I'm going to talk about the volume of the prism first. Okay, so this is a three-dimensional diagram. So you need to visualize a lot of 90 degrees. So first of all, it's a prism. So if you need to find the volume of the prism, you need to get the cross section. So there are two cross sections here. So the first cross section is a small trapezium. So you need to find this small trapezium first. And then you need to find the big trapezium. So be careful of the big trapezium. So the height of the big trapezium is 5 and 1.5. So it's actually a 6.5. So some students actually make a mistake in the second trapezium. So these two trapezium make up the cross section. It makes up the cross section of the bun. So you need to add the trapezium. You can do the trapezium separately first. Then you add them up, so you get the cross section. And once you get the cross section, you just need to multiply with the length. So I think if you can get the trapezium correct, most people will get the volume correct. It's not a very big issue. Okay, the difficult part is subsequently, they are asking for the sloping roof. So there are two roofs that you need to take note of. Okay, and the question also mentioned that it has two rectangle sloping roof. So being a rectangle, that means there's just a 90 degree here. So there will be this piece of rectangle. So there'll be a bigger piece. This piece is more visible to you. Okay, so I'm going to talk about this piece first. So for this piece, I need to find what is this. And I got to do it by the Pythagoras theorem. So I got to do it by the Pythagoras theorem. So actually, I'm using this part to do a Pythagoras theorem. So this part will be a 2.5. So I'm using this trapezium to do the Pythagoras theorem. So it happens here. So this is the bigger one. So this is the one, that's where the 2.5 come from. So a lot of students, they make careless mistake. They didn't write it as a 2.5. They accidentally wrote it as a 1.5 here. So the 1.5 is not correct. So you got to look carefully. This is a 4. And if the whole height is a 6.5, then the tiny part should be a 2.5. So you need to do a Pythagoras to get FE. So that's what I did. I did a Pythagoras to get my FE. And I didn't bother to press out the value of FE. I just leave it in a square root because later on I'm going to multiply by the 25. So if I can find FE multiplied by 25 will have given me the bigger piece of the rectangle. Now it is the smaller piece that's the issue. So I'm going to show you the smaller piece. The smaller piece is not very visible. It's here. So it doesn't even look like a rectangle to you. But the question already said, this is a rectangle. So it's a rectangle that looks like this. So it's AG, and it has a length of 25. Okay, so it doesn't look like a rectangle. So you also need to find AG. Again, I'm finding AG using a Pythagoras here. So this one will be 1 unit and 6 units. So that's how I draw the So that's how I find AG using the Pythagoras that I drew here. Okay. So, and I also didn't bother to work out AG. I just leave it in the square root. So if I use AG to multiply by the length, I will get the rectangle. So essentially, I'm just adding up two rectangles. But you need to do the Pythagoras to find the side of the rectangle. So this may be a bit more difficult for some of you if you couldn't visualize the 90 degree. Otherwise, I think these two parts is quite all right. The most difficult part is the angle of elevation. So if you look at the question, it is the angle of elevation of P from D. You are projecting from D to reach P. So look for D and you are looking up. So you are standing here, you are looking up. So where is the angle? The angle has to be vertically down. So I actually got to drop the height down, vertically down, and I will form a 90 degree here. So this is the angle that I'm looking for. So here comes the difficult part. If you can identify this angle, you must visualize that this is a 90 degree because this part is vertical. And this is horizontal because it's on the ground. So that's how I gotten the 90 degree. And if you can come to this conclusion that there is a 90 degree there, the next thing is, how are you going to get the 6.5 here? The 6.5 essentially is this part. Can you visualize? They are actually the same. Okay. And this 6.5, and actually is connected here. This is the second half of the bond. So if you can deduce the 6.5, the next challenge is to find dk. The next challenge is to find it on the ground. So you must see that this is another 90 degree on the ground. It's actually another 90 degree that's not obvious. So it's something like this. So there's a 10 here. Then there's a 25 here. So you must see that there's a 90 degree that is on the ground that is not very obvious. So that's a challenge. Then you can find dk by doing the Pythagoras. So you need to form out where is the angle first. After you form out the angle, you got to look around you to find the individual length. So the 6.5 can be found by visualizing. It's the height. And then the one that's on the ground is more challenging. You actually got to see as a Pythagoras theorem. So that's what I did. Okay. And then from there, you perform the tangent to find the angle of elevation. So I will say this is the challenge part for this question.